All right, hi everybody. My name is James, and this is going to be a talk about scientific programming. I'm not sure how much of that we've seen so far in this conference. My day job is that I'm a researcher at the University of Waterloo, and I do research in machine learning and neuroscience. And a big part of that is doing, using machine learning algorithms, obviously. So I'm going to talk about a library that I've written that makes it easier to do machine learning. So if you've used machine learning algorithms like neural networks, support vector machines, decision trees, and so on in the past, you probably know that they have a lot of hyperparameters. So it's not just like you use the algorithm. You have to choose a lot of regularization amounts, pruning strategies, numbers of hidden units, types of optimization algorithms. All kinds of choices go into how you set up your machine learning system that have a pretty big impact on how well your thing actually works. And there are rules of thumb, there's domain expertise, but ultimately, the way to set all those hyperparameters is kind of trial and error. So what I've written is a library that kind of goes through that automatically. And in fact, when I think about hyperparameter optimization, I'm even including what you might call pre-processing. So if you want to do, like for example, email classification or something that's like a canonical machine learning task, you start off with emails, which are in text, and you have to first convert the text into numbers so that you can classify them with like a support vector machine or something like that. And the way you get from text to numbers isn't even all that straightforward. There's lots of different algorithms for doing that too. They have their own hyperparameters. So really, when it comes to putting together a whole system, there's a lot of choices you have to make. Anyway, so Hyperopt is about finding better configurations so that your classifier works better. If you're making a library or you're trying to distribute the software to other people, it's important to let them also have success. So you want to be able to automate the mechanical work of configuring these things. And as a kind of side effect, it gives you fuzz testing for free. Because when you run an algorithm configuration program on top of a code base that you've used, like you might have some kind of intuitions about like corner cases, which you probably don't have to worry about. Like these are crazy settings. You would never really do that. Your algorithm will totally do that. And it will break your code, and then you'll have to fix it. And by the time it's through, your code will be rock solid. So how do you actually use Hyperopt? You have to describe a search space, as in like what's the domain that we're searching. I mean, an objective function is going to assign scores to the points in your search space. So when you're trying to tune machine learning systems, you might take the accuracy on a validation set or something. If you're trying to optimize different kinds of objectives, that's fine too. But whatever it is the thing that you're optimizing, you need to obviously encode that in order for Hyperopt to work. Having written down the search space and the objective function, you just call Hyperopt's fmin function, which is kind of similar to what you might have seen in SciPy or MATLAB or something like that. And then at the end of the day, all the different points that you tried during your search get saved in a database, so you can analyze your results. I'm going to show two pieces of code here. The first one's kind of easier to understand, and the second one has to do with machine learning. So this is using Hyperopt in one slide. You import some stuff at the top. Then you define a search space, not in terms of bounds or like a number of dimensions. A search space for hyperparameters is a random process that samples valid configurations. So here, this search space has 2 points in it, 2 dimensions, which we've named x and y. And what it means is the search space is all the possible points that you could get by sampling 2 normal distributions. So that's actually like all of like a 2-dimensional vector space, but there's more elaborate search spaces which we can set up that Hyperopt can take advantage of. So being able to encode your domain expertise in terms of where to look is a big part of what makes hyperparameter search efficient. The second thing you have to do is make this objective function. So this objective function here takes some arguments. Those are going to be the 2 x and y values that we would have sampled from the search space, and then it returns a number, which is basically good if it's small. And then we minimize it by calling fmin. So we say minimize this function on this space that we defined using this algorithm, and with this many trials that we're going to allow for. So by different kinds of algorithms, you can have more or less efficient spaces, more or less efficient searches. Hyperopt comes with a couple of algorithms. And then, so the way this actually all translates into machine learning is going to be on this next slide, where you define a huge search space. We're not going to search 2 dimensions. We're going to search through like all of the configuration options of like algorithms that you find in scikit-learn for doing, here we have got support vector machines and decision trees. So we're going to say that our classifier is a choice between either a decision tree with like all these different possibilities, or a support vector machine with all kinds of different possibilities that have to do with support vector configurations and so on. So you just kind of write all this stuff down, and then you can call fmin on it, and it can figure out the best classifier for your data. Anyway, it's a lightning talk, so I'll just cut to the summary here, if I can get the mouse in the right spot. Project's on GitHub, check it out. Basically, Hyperopt so far is undefeated in academic terms. So I've done some papers about like trying to configure neural networks for computer vision and doing some deep learning. And so far, like it has revealed that people aren't actually all that good at tuning machine learning systems, even though they are the domain experts, right? So it's been pretty interesting technology to develop and work with. So anyway, I wanted to give this talk about it, and thank you for your time, and enjoy your lunch.